How is text converted for language models? The processed data from documents is typically stored in a vector database, and it includes fields to identify the source document. This process is often called ingestion, and it's a key part of systems like RAG, Retrieval-Augmented Generation. The goal is to convert a document into a format that an LLM can efficiently search and understand. The core storage, chunks, and vectors. Instead of storing the entire document in one piece, it's usually split into smaller, manageable chunks of text. The data stored for each chunk is multifaceted. 1. The content itself, the raw text of that specific chunk, often stored in a clean format like Markdown, to preserve structure like headings and lists. 2. The vector embedding. This is the key to semantic search. For each chunk, a mathematical representation, a long list of numbers, called a vector embedding, is generated. This captures the meaning of the text. 3. Source metadata, a set of key value pairs that identify where the chunk came from and provide context. This usually includes source_ID or document_ID, a unique identifier linking back to the original document. Chunk_index, the chunk's position in the original document to help maintain order. Source_type, for example, resume, PDF, GitHub_repo. File name, title, author, standard bibliographic information, page_count or page number to provide specific location context. 4. System data, other information to help with search performance, like token_count to manage an LLM's context window. This structured data is often stored in two related database tables. A sources table for document-level information, title, type, file path. A chunks table for the actual content, its embedding, and a metadata column, often a JSON blob, that contains the source_ID and other specific details, rather than using a hard foreign key constraint. The storage infrastructure. This data is typically stored in specialized database systems known as vector databases, like Milvus or PostgreSQL with the PG vector extension, which are optimized for storing and searching vector embeddings. These systems allow you to efficiently find the chunks most semantically similar to a user's query. For even larger scale data projects, processed documents might also be stored in cheaper, scalable object storage, like Amazon S3, in optimized columnar formats like Parquet for efficient training of LLMs, while maintaining links to the original source. The overall flow. To summarize the full picture. 1. Parse. The original document, PDF, Word, etc., is parsed. Tools like Dockling or Markdown are used to extract the text and structure, often converting it to Markdown. 2. Chunk. The resulting Markdown is split into smaller pieces, chunks. 3. Embed. An embedding model generates a vector for each chunk. 4. Store. The chunk's content, its vector, and all its metadata are saved in the vector database. This architecture ensures that when you ask a question, the system can quickly find the most relevant pieces of information from your documents and provide them to the LLM, complete with a citation pointing back to the original file. Anything you put into a cloud AI like ChatGPT is saved and probably used to train the model. You can protect your private data by running local AI models on your PC, Mac, or network. Applications and models are available for free. I can help you get up and running. Contact me for a free demo. You need a PC or Mac with Windows 10 or better, 8 gigabytes of memory, no GPU. More memory is better, but you can run 3B models on 8 gigabytes. They can be impressive. There are several free tools you can use for local AI. GPT-4, ALL, LM Studio, Ollama, and anything LLM. I prefer GPT-4 ALL and LM Studio. I have published more than 700 blogs on AI in the past 3 years. If you get value from these blogs, please join my Patreon as a member at the $2, $4, or $8 per month level. https://www.patreon.com/Steve Hovland. I have a new group on Facebook called Local AI by Steve Hovland.